All right, so here we are with the coding phase for Part 10, Lives and Levels. Logan, let's go ahead and jump over to Visual Studio. Start coding it.
Back over to Precision. And we're already in the game class, so let's jump up to the very top so we can address the fields. So I'm going to scroll down to just below the screens section. And let me jot down a comment for level. So we're going to have our 3 level fields.
Okay.
First of which is, of course, the level field itself, the current level, which we're simply going to call level. And then the 2 constants to control enemy and cell counts. So we're going to have first constant. Both of these will be integers. First is going to be base num cells, which we'll set to 2. The next one will be constant integer base num enemies.
I'm missing one underscore.
Let's get that underscore. Base num enemies will be 1.
Okay.
Alright, now we can look at our lives fields. So the fields for lives, there's going to be 2 of them. One is the field for lives itself, to track the current number of lives, and the second is the initial starting lives, which I'm going to put down as a constant integer called starting lives, which we'll set to 3, since the game begins with 3 lives. Alright, now we can take a look at the 2 properties, because we have a base number of cells and enemies and a level, but we need to turn that information into a final level cell count and level enemy count. So we'll jump in just before the first method, just before the constructor actually, and we'll put in, I'm going to drop down a region since I'm going to set these up as properties. Make a region. Now these are going to be private properties. I'm going to make them private since they're only integral to the inner workings of the game itself and don't need to be accessed outside. So I'll make this region for private properties. Alright, first of which is going to be the level cell count. This will be a private integer called level cell count.
There you go.
And it's going to have a get accessor which returns the current cell, or was that, hang on, I forgot what that's what's called, base num cells. So return base num cells times the current level. And that will result in the final number of cells for this field. The second property will be another private integer, this time level enemy count. And it as well will have a get accessor that returns the base num enemies times the current level. And that takes care of the properties, so I'm going to collapse down the region and we can move on.
Okay, next thing we're going to do are the gameplay methods, the begin game and the begin level.
Alright, for these methods I'm going to jump down near the bottom of the game class, and I'm actually going to jump in just above the regions for screens. As a matter of fact, or not just screens, but let me start collapsing some of these regions.
Sure.
So I'm going to collapse down the screens region. I'll also collapse down the helper methods and the utility methods. So here we are right below the draw method in game. I'm going to make a one last region. This is going to be a region for the what I'm going to term gameplay methods. And this is where we can put our begin game and begin level. Both of these methods are also going to be private. They aren't going to return anything. And the first is begin game. And the second is a private void begin level. Alright, and while we're here, I'm going to go ahead and put in the full implementation to both of these.
Okay.
Since begin game is very simple and begin level consists of mostly things we've already seen.
Mm-hmm.
Now begin game is going to need to do 2 things. It's going to need to set the level. So this dot level, we'll initialize that to 1, since the game always begins at level 1. And the second thing we'll do is we'll set the number of lives. So this dot lives to its initial value, and now its initial value is held by the constant starting lives. And that takes care of begin game. Now we can put in the implementation for begin level. Now the first thing that has to happen on any new level is we need to account for the fact that there might have been a past level that has just been played. And that means we need to clear out all of the actors and all of the bars that might be held in that level. So we're going to address actor first and tell its actors list to clear. And that will remove all actors that may still exist. Then we'll turn around and we'll look at bar and tell its bars list to clear out any bars that might exist. Now, once we have these cleared, we'll have a completely, or what you could say, clean playing field. Now we can go about and adding the proper cells and enemies for this level. Now we're going to address cell first, so that cells draw behind everything else, so behind enemies and players and stuff. So to add cells, we'll once again call on the cell add cells method. Add cells is first going to be looking for a number of cells, which we now have given by the level cell count property. And then the rest of the fields are things to create individual cells, like a texture, so we can give it cell texture. A healthy color, we have a field that contains cell healthy color. And finally, we have another field that contains cell dead color. So we'll pass all of those along to add cells, and that will get our cell field set up.
Okay.
Now we can turn our attention to enemies. So what we'll do is we'll look at the enemy static method add enemies. It's going to be looking for a number of enemies, which we have given in level enemy count, and then its texture and some speed properties. So we'll give it the enemy texture, and then for the base speed, we have the enemy base speed constant and the enemy speed variation constant. So we'll plug both of those in. And of course, these should look very familiar from the load graphics content, where we've done almost the exact same thing, except we didn't have the level cell count and level enemy count properties.
Yeah, we were just plugging in hard numbers for how many cells or enemies we wanted to see created.
Alright, so now we've got cells and enemies, we need to create the player. And not only create a new player, but to make sure that that new player is stored in the player field. So what I'll do is I'll say this.player, so the game's player field, is equal to a new player. And the player needs a texture, which we have held in the player texture field. That has one created. Now we need to call reset, because we need the player positioned in the center of the screen, and when the level begins, we want to make sure that the player begins with invincibility. So this.player.reset, and reset's going to take in the amount of invincibility time, which we have stored in the player invincibility time field.
And then finally, we need to get that time until attack initialized to the cell attack interval.
Right, so we have our initial delay set up. So we'll take time until attack and set that to cell attack interval. Now, of course, both of those being fields, we could probably do something like this.time until attack, this.cell attack interval, just to make it match up with everything else.
Okay. All right, so now that we've got that done, we can turn our attention up to the load graphics content and pull all of that unnecessary code out now.
All right, we can scroll all the way back up into load graphics content, and we can take all of this out. Time until attack is handled properly. All of these things are actually handled inside a begin level, so we'll erase all of them.
Very nice. Of course, now, if we were to try running things, it's not going to exactly work right because we're not making any proper calls for begin game and begin level. So let's go ahead and handle all that stuff. Let's go ahead and get the game and level such that it can begin.
So game, begin, and level are going to be handled by states due to input. So what we'll do is we'll jump down to the game state section inside of update, and we can address the title screen first. So inside of the title screen, obviously nothing happens immediately because we have to wait at that screen.
Right.
But when we're at that screen, if the start button is pressed, then the game needs to begin. So I'm going to jump into this area of code and say this.begin, or excuse me, just a call to begin game. And then I could have used this if I wanted.
Oh yeah, that's good. So we'll call on that. Now we need to change our game state because we don't want to jump straight from title over to playing. We want to jump from title to our level change. Very good.
And then we can jump down to the next state and put some input handling for level change. As a matter of fact, I could steal this line to get a button input, paste that in, and take that back a little. Now in the level change screen, we're looking for the A button. So I will change the input line to look for A instead of start. Then inside of level change, we need to have two more things happen. After level change, after the A button is hit, we need to begin the level. Then after we begin the level, change the game state. So this game state will be set to game state.playing, and that's where we actually get to playing. So begin level sets up a level, then we change state over to playing so we can begin playing that level.
Excellent. Now we can go ahead and build and give this a test.
Alright, so we build, waiting, and everything works. We're not using lives yet, but otherwise the build has succeeded. So if we run, we're presented with the title screen. If we hit start, now we're presented with the level change screen. And looking at this, there's a few things we could address. We've got a level number, a cell count, and an enemy count, which exists now. But to continue testing, we can go from this screen, press A, and the level begins, and then we can begin playing.
Excellent. So it really looks like it's all starting to come together now.
So that series of events has worked. We went from title to begin game, and then a level change, then from level change to begin level, and started playing.
Very cool. Well, let's go ahead and jump down to our screens region and adjust that level change screen so that it takes into account our level number, enemies, and cell numbers.
Okay. So if we jump down to the very bottom, let's go back into that screens region and look at the level change screen. Here we had the temporary brackets put in. So I could erase those back out now and then add on to each of those their actual value. So for level, that would mean this dot level for the level field. For the number of cells, again, take out the temporary number, and then put in this dot level cell count. Let's see. Then for enemy, we can put in this dot level enemy count. So if we run now, and the level change screen, we have level 1, 2 cells, 1 enemy.
All right,
if we begin, that's exactly what we get.
Let's go ahead and jump to level 2.
Well, level 2 is going to be tricky. Because
we're not advancing yet. Haha, here I am getting carried away again. Okay, very good. Though level 2 is going to work just fine. We'll see in just a second. But before we get there, let's go ahead and get the player's lives set up now so we can lose lives and the game can actually end.
Okay. So what we need to do is, for losing lives, we need to jump into the code that handles player death. And that comes right after we do a check for collision with enemies. And this is how we're handling death right now, is just to change the state. We instead need to do a few checks before we actually set that. The first thing we need to do is to decrement the number of lives, because at this point we've just collided with an enemy, so we lose a life. Now, after we've lost that life, we need to turn around and check the lives value and see if there are any lives remaining. Because if there are, we can go to a died state and then continue playing. If there are not any lives remaining, then we enter the game over state. So let's see, if this dot lives is is greater than 0, then we have lives remaining, and we can enter the died state. Otherwise, if lives was not greater than 0, then we've run out of lives. So we'll set the game state to game over, and the game will end.
So now we can go ahead and jump in there and test that out.
So if we start, and let's see, we die once, we died, twice, we died, last life, final death,
game over.
Game is now over.
Excellent. Of course, pressing A right now doesn't do any good because we don't have any sort of state changing in our game over state.
Right, so now we need to move on to
the game over state.
Adjusting the game over state. So now, basically, in the implementation plan, what we need to handle is the game can restart. So what we'll do is we'll jump down to the game over state. And I'm going to copy the input line once again. And jump down, block it in. Take that back. And what do we need to do? Well, we need to change the state back to title in order to get back to the title screen. So this dot game state set to game state dot title, and that's it. Going back to title kicks everything off because everything has already been set up to go from title and clean everything up and continue.
That's right. So let's test it. Good.
All right. So first death died. Second death died. Last life now. If we die, game is over. If we hit A, we go back to the title screen. If we hit start, we go to the level change screen. If we hit A again, things begin over.
Perfect.
So I can try dying again. So first death, second death, game over again, so that we can see that the lives are in fact restarted. We regained 3 lives when we restarted the game.
Excellent. Okay, so that takes care of all of that. Let's see, what do we need to go ahead and get in place next? Well, I guess we're ready to start seeing some advancement take place for our levels.
Right. Now, if you remember, the levels advance when we run out of savable cells. So that means we need to put in a check to see when we run out of cells. And the place I want to put that check in is inside of the playing state, probably right after we do the time until attack. Anywhere before we do the actor loop would work, but I'm going to set it up right after the time until attack decrement. Now, all this is going to be is a simple check to see if we have any cells left, or rather if we've run out of cells.
Right.
And to do that, we're going to look at cell because it holds the static cell count property, which has its internal field. So with cell count, we want to check if cell count has run out, so if it's less than or equal to 0. So in that case, if we run out of cells, what do? Well, we need to take the level and advance it. So this at level is incremented. Then we need to set the state. So we'll set the game state back to level change. So game state.level change. And then finally, once we've set these things up, there's no reason to go through all of the actors at this point,
right,
since we know we're going directly back to the level change state. So what we can do is we can break out of the loop out of this case entirely, continue on to another iteration of update where we'll jump over to level change. So basically we more quickly get to here without having to recalculate everything that's unnecessary.
Very nice.
So, well, now we can try it out. So let's see, I'll save this cell. If I let that cell die, we run out of cells. Then the state kicks over to level change. The level is advanced now, so it's level 2, and then the enemies and cells are increased accordingly. So now we're on level 2. So if I save some of the cells, then we get to level 3. And now the levels are advancing. So if I die, everything's still okay if I don't die too many more times. Well, now I'm on my last life, but now we've made it to level 4. Even more enemies, but I'm on my last life, so if I die, I get a game over.
Excellent.
And everything begins over. So let's check that as well. If we begin over, what happens? We restart at level 1, and everything continues properly.
Get those 2 cells? Or one of them? Check it out. Does it restart properly? There's a problem. We have no savable cells, but we did not advance. Logan, go ahead and implement that text drawing in there just to show them how many savable cells remain.
Right, this is interesting because up until now, I mean, we've been very good at resetting things. We've reset all the actors, we've reset the level, the lives. So why have we entered a state where we don't progress, where we've run out of cells and we're stuck now? And we need to look at this value, cell count, because if cell count reaches 0, we should have advanced. We saw the one cell get saved and the other cell die. Why didn't we reach 0?
Exactly.
So to try to uncover why this isn't reaching 0, what I'm going to do is jump down to draw and put in a temporary debug line where I write out the cell count. So what we can do is make a quick call to sprite-fetch draw string. Draw using the same main font. And we want to draw the text cell.cell count, so we can visually see what our cell count is doing at all times. Of course, I'm going to have to dump that to string in order for it to draw. For the position, I'll give it a new vector 2 and offset it maybe 10 by 10 off the corner of the screen. Draw with the color white. And let's see what this looks like. Now as we begin, we see we have 2 cells, so the cell count should actually be 2. And we get a value of 2. If one of the cells dies, it goes down to 1. If I save the other one, it hits 0 for a second and then flickers over to the level change screen. So if we begin here, we have 4. Now let me die, because we saw that the problem actually came from dying, losing all the lives, and beginning the game over. So here we have 4 cells, and if you're going to die in the process of me trying to lose all the lives, so we're down to 3, and down to 2. So right now, as the game is in a state of being over, the cell count is currently 2. So we'll hit aim, we'll hit start.
There should be 2 cells when you go into this first level.
Right, we're going to have 2 cells, and one would think that the cell count is supposed to be 2.
But
look
not.
What's what happened. It's 4. So as I save cells, we drop back down to 2. And this is what I was talking about with the cell count being separate from the actual cells list, or excuse me, the actors list. And that means we can use up cells, kill cells, and kill them off. But if that number is offset improperly, like it is here, we began with a number of 2. So what's happening there is we had finished the game, got a game over, and had a cell count of 2. Then we began the game over and added 2 more cells to the first level to result in a cell count of 4. So in order to remedy this, what we need to do is make sure that in begin level, before we create everything, that we make sure that our cell count is set to 0.
Okay.
Now, of course, I believe that cell count property is read-only. So what I'm going to do is I'm going to add a method. What I'm going to do is add the method reset cell count. So this is going to be a public method. I'm going to make it static because we're trying to get to that static field. And it's not going to return anything, so it can be void. And we'll call this reset cell count. And all we have to do in here is set the cell count field to 0.
Perfect.
Then back in game, we can say after we clear everything, let's tell cell to reset the cell count so that if we had died with some cells left on the board, that those cells get cleared out and we can continue with only the number of cells given by the call to add cells.
Okay.
So let's test to make sure that that's fixed the problem. So let's progress. We go from level 1 to level 2. In level 2, if I manage to get a game over, now in this case we have 3, but if we jump back to the title screen, back to the level change screen, the cell count has returned to 2. And if both of these cells die, we begin advancing properly. So we've now fixed that bug, and levels will advance even after our game restart.
Okay. And with that, Logan, that's everything that we set out to accomplish in Part 10. So, yeah, we now have lives in place. We now have level advancing in place. We can die and run out of lives and reach a game over state. Everything looks fantastic. So that is going to wrap up this video. In the next part, we're going to take a look at getting the score and the HUD in place to really start tying all those final elements into a fully functional game. So that's going to wrap this video up. Thanks a lot.